Chapter 5, Section 1 starts talking about polynomial functions. So there is some vocabulary we need to get out of the way first. First thing we're going to talk about is a monomial. A monomial is a real number, a variable, or the product of both. The requirement between a monomial is that any of the variables that have exponents have to be whole number exponents. So there are a couple of examples there listed for you. Just keep in mind, in order to be a monomial, it has to be a number, a letter, or the product of both, where any exponents are whole numbers. So negatives, fractions, and decimals aren't allowed in exponents. If you look at the number in the air, on the letter itself, that's called the degree of the monomial. So anytime you want to find the degree, you look at the little number in the air, the exponent, on the letter, on the variable. So we're going to talk about the degree of each of the examples on the screen. I'm going to talk about the first one. For x, its degree is 1, because even though the 1 isn't written, it's understood to be the exponent. For the second one, negative x cubed, its degree is 3, because the variable has an exponent of 3. Third one's a little trickier. That 5, its degree is 0. Because it doesn't have a letter, so there's no exponent, it makes it a 0. The fourth one is 1.41x squared. Its degree is 2. And then the last one, negative 2x to the 15th, has a degree of 15. The degree of a monomial, one term, is the exponent on the letter. Anytime you put monomials together by adding or subtracting, it's called a polynomial. The word or the prefix poly means many terms. So if you put a monomial or a whole bunch of them together by adding or subtracting, it's considered a polynomial. And the degree of the polynomial is the greatest degree there. So you're looking for the biggest degree. That's the degree of the polynomial. So we're going to go through and talk about whether the following are polynomials, and if they are, we'll talk about their degree, and if they're not, we'll say why they're not a polynomial. So number one is a polynomial, because both 5x and 1 are monomials. Adding them together is okay, so this is a yes. The degree is the highest exponent on the letters. The highest exponent on the letter happens to be right there, right by the x, so its degree is 1. Number 2, below it, doesn't look like it, but this is also a polynomial, because by definition, a polynomial is a monomial or a bunch of them added together, so this one's a monomial, whose degree is 0, because there is no variable, which means there's no exponent. Number 3 is not a polynomial. It is not a polynomial because the exponent there is negative, and you're not allowed to have negative exponents. They have to be whole numbers. Number 4, before we can talk about whether it is or not, I'm actually going to fix it. Not sure if you remember the rule or not, but anytime you take a variable from the top to bottom, or bottom to top of a fraction, you flip the sign. So 7 over x to the 4th is the same as 7x to the negative 4th, which makes this a no, because you cannot have negative exponents. Number 5 is a yes. It's a whole bunch of monomials added together, whose degree is 3. And that's because of the little 3 in the air there, not because of the big 3 in front of x. 3 is the highest exponent available. And number 6 is a no, because you have a fractional exponent. You cannot have fractional exponents. A polynomial is considered in standard form when the powers of x descend from the highest to lowest exponent, something we talked about last chapter with quadratics. And you should also add combined like terms. Sometimes they'll give you an expression that doesn't have like terms combined. You need to do that first. There's a lot of vocabulary that we need to go over now, and I'll try to give you some hints as to how I remember each and every one of these. All of these words describe a polynomial by the number of terms. The suffix meal, M-I-A-L, stands for terms, so that might make it a little bit easier for you to remember. A monomial means one term. Mono means one, and meal means term, so one term. 2, if it has 2 terms, it's called a binomial. Like a bicycle has 2 tires, a binomial has 2 terms. Number 3 is a trinomial. A tricycle, or a triangle, have 3 wheels or 3 sides, so a trinomial is 3 terms. And then as soon as you reach 4 or more, you just call it a polynomial of however many terms it has. So if you have a polynomial that has 6 terms, you call it a polynomial of 6 terms. That's as soon as you reach 4. The other set of words that we're going to use classify polynomials by their degree. These are a little bit trickier, so I'll again tell you how I remember these. If the degree is 0, it's called a constant. If the degree is 0, it means there's no letter there and numbers are constant. They don't change. If the degree is 1, it's called linear. I always remember that y equals mx plus b is a line, and the power on x there is always a 1. That's how you know it's a line. Number 2 is a quadratic. We've been thinking about these forever, working with them in chapter 4. Just don't forget, quad makes you think 4, but it's not. It's 2. Quadratics means 2. A 3 is a cubic. If you look at a cube, that is a 3-dimensional shape. 3 is cubic. 4 is quartic. There are 4 quarts in a gallon, or 4 quarters in a dollar. So quartic is 4. 5 is quintic. Quintuplets means that somebody has had 5 babies, so 5 is quintic. Now, as soon as you reach 6, it just becomes that degree. So if you had a degree of 7, you would call that a 7th degree. As soon as you reach 6 or higher, it's just that degree. They're going to ask you to write the polynomial in standard form and then classify it by its degree and number of terms. So, taking a look at number 1. I don't see any like terms, but it's not in order. So I'm going to start with the order first. The 4x to the 4th has to come first. It's the highest exponent. But then I'm going to write the negative x cubed next because it's the next highest. And then the negative 5x squared, and then the 1. Now, we typically do the degree first. So the degree here is a 4. That makes it a quartic. And the number of terms, it has 1, 2, 3, 4 terms. That makes it a polynomial of 4 terms. And that's it. So standard form first, and then classify. Number 2, I don't see any like terms, so I'm just going to write them in order. Negative 5x to the 5th comes first, then minus 6x squared, then plus 3x. According to its degree, a 5 is a quintic. Back on your notes if you have to. And then the number of terms. There's 1, 2, 3 terms, which makes it a trinomial. A quintic, a trinomial. Pause the video to complete the you try it. I do want to take a moment to point out when you're doing these questions, if there are any like terms, you have to combine them first. I know that that happens in the homework. Combining like terms before you classify helps you to classify them correctly because the number of terms won't match after you combine them. Always combine like terms when writing something in standard form. As a wrap up for today we are introduced to polynomials and how to classify them both by their degree and number of terms.